of the disaster. So we're going to look at both physical proximity as well as what you might call social distance. So do people donate differently to people who look like them in terms of race or in terms of income? There are going to be important implications there for government's role in stepping in if there's inequity in those responses. And then media coverage of the disaster was the number 3 cause that they found here. And that's also something that we want to look at. So overall, first of all, does media coverage increase the donation response to help support the victims? But also, does it ameliorate any sort of inequities in the response, or does it exacerbate those? Those are all things that we're planning to look into. So as I said, I'm going to talk about what I think are a few different papers. I sort of view this as an agenda in which the sort of broad question is whether these transfers respond to the needs of the people who are receiving the transfers. And so we first asked whether the supply of donations is fixed. So this has been sort of a troubling question in the charitable giving literature. There are a lot of studies, with a properly designed experiment, you can very nicely estimate the causal effect of any sort of policy on increasing donations to a particular cause. But what you don't know is whether those increased donations, assuming your intervention is successful, you don't know whether those came at the expense of some other cause, right? And so we're trying to get at whether, in fact, total donations increase when certain people have additional needs, or do people just kind of shift around the money that they would have donated regardless? We also want to look at whether these transfers, both public and private transfers, whether they depend on the identity of the victims. So as I said, we want to look at the race and the income levels of people who are affected, and we want to see, do people provide more support to other people who are like them? So there's a long literature in sociology, for example, studying in-group effects versus out-group, and people's affinity for people who are in their in-group. And so we want to see if there are differences in giving based on the identities of the victims, in which case that suggests that some public response could help to address those inequities. And then, as I mentioned, we want to look at news coverage as well. So we want to get a sense of whether the news coverage increases how much people give, and also whether it increases the equity of these donations, whether it causes people to donate to people who they otherwise might not have donated to. And so this, again, is an agenda, I would say. So the first sub-question here is one that we addressed in a paper that is now published. And so I'm going to describe that paper in brief, and then I'm going to talk about what we've done so far on questions 2 and 3. I think right now that those are each a paper, but it's very much work in progress. So this is one of the first times that I've presented some of this work, and so I very much appreciate any feedback that you can offer me. Also, I guess I should say that you are all free to put questions into the Q&A. So Mark, I believe, is monitoring that, and we'll maybe raise a few questions during the talk, and I'm happy to answer those at any time. And then I will try to leave some time at the end to have more of a Q&A as well. So here's a picture of some damage that was done by a tornado. So we are kind of looking at data on tornadoes and floods and hurricanes. We sort of like tornadoes as kind of the optimal natural experiment, in that a tornado strikes a very specific area. And so we can identify treated areas that were either hit by the tornado or were close to the tornado, and control groups that are further away from where the disaster occurred. So here you see what is a bit of a limitation, in that unlike hurricanes, where we have a nice measure of wind speed and how severe the storm was, regardless of where it hit, for tornadoes, we don't really have that. We have how much damage it did. So here it would have been a little bit of property damage and maybe not much else, because it looks like it just went through a cornfield. And so that is a limitation, in the sense that our severity measures are kind of limited to fatalities, injuries, and property damages, which in themselves are going to sort of depend on where the tornado hit. And so that's going to be a complication that I'll talk about. So for these tornadoes, which we have data on from the National Oceanic and Atmospheric Administration, we observe each of those severity measures that I just mentioned. We observe those for all tornadoes on record going back to 1950, which is pretty nice. The outcomes that we're looking at don't go back that far. So the tornado data, in a sense, is better than the transfer data. We have pretty similar data for floods, and so that's kind of the next thing on our to-do list. But as I say, we think tornadoes are a really nice natural experiment, so we've been focusing on them thus far. Much of our data is at the zip code level. So we're going to have donations, for example, which have the donor's zip code attached to them. And so a zip code essentially gives you a geographic area, except that zip codes change a little bit from time to time. So we have taken these postal bulletins that the Postal Service creates, which talk about when they change zip codes. And we've used those to create a set of super zips, which are basically combined zip codes that are geographically the same over time. And then we've got GIS data where we can figure out where is the center of a zip code. And so we can create a distance measure between the zip code and the areas that are affected. So we have the starting coordinate and the ending coordinate of any given tornado. We will assume that the tornado just follows a straight line between those 2 points, which is obviously an assumption. In reality, tornadoes don't move in straight lines. So there's going to be some measurement error there, but as you'll see, that's not going to be too much of a problem for us. We're going to look at distance between the donors and the storm, but a lot of times we're just going to be looking within the same state of the storm, which seems to be what matters a lot. In addition, so we've got money that is directed towards the victims of these storms. So FEMA is the federal agency that is providing support. We have data from them on how much support they've provided. We haven't done very much with that at this point, so you won't see any of that today, but that's also something very high on our to-do list. We have focused, in particular in our first paper, on this tax data that we can get from the IRS, which is at the zip code level. So we have sort of a geographic measure of how much people donate and claim on their taxes. So when you make a donation, you get a tax deduction for that. And so it doesn't matter, what you donated to. This is going to capture all of people's donations. So we're going to refer to this as a measure of total giving. We also have the money that is received by the charities, and so you'll see that as well in the paper that we've completed. And in the work that we are turning to now, we are looking at donations to the American Red Cross. So this is one of the major charitable organizations that's providing support for natural disaster victims. And so you can imagine that in total giving, as you observe in the IRS data, the disaster donations are a relatively small percentage. And so we're going to get sort of imprecise estimates, whereas with the American Red Cross data, we can get much more precise estimates. And so we can look at heterogeneity by, for example, distance from the disaster or social distance between the donors and the victims, things of that nature. So in our published paper, we have this graph, which kind of shows you both the locations of tornadoes and where the IRS data cover. So the red areas in here are areas covered by the IRS data, even with some restrictions that we impose. So the IRS sort of hides some of their data on smaller zip codes because they don't want you to figure out who is a particular donor. And so the gray areas are kind of showing you places where there are not that many individuals. And so in certain years, those don't show up. So we just kind of drop all of those. We just kind of focus on the red areas. And then the black dots and black lines are the fatal tornadoes that occurred between 2002 and 2017, which were the years for which we had this tax data. And so you can see, I think, first of all, there's a big difference, right, between places that get hit by a lot of tornadoes and places that don't get hit by a lot of tornadoes. So our empirical strategy here is not going to be comparing Kansas, which has tornadoes, with California, which does not, but rather it's going to be controlling for time invariant differences between different areas and looking at what happens within a location when you have a relatively severe storm. And so I'll show you a couple different sort of variants of estimates that we've gotten. The sort of general idea here is that we want to estimate donations as a function of severity and a few other things, right? So donations, we're going to take the inverse hyperbolic sine, which is basically like taking the natural log, except that that natural log is undefined when donations are 0. The inverse hyperbolic sine actually allows those donations to be 0, and we're going to use that transformation throughout. Severity, similarly, in our published paper, we use that inverse hyperbolic sine transformation on fatalities. But in our ongoing work, we are looking at different measures of severity and using principal component analysis to try to combine those measures to get at, you know, what is the underlying severity of the storm, which you know, could be different depending on where it strikes. We have some time varying controls. So I think in our published paper, we use location time trends. But I think the key things here are the fixed effects. So we have a zip code fixed effect, and we have year dummies or day dummies if we're running regressions at the daily level. And so that is where we look at changes within a location over time, rather than, you know, comparing different locations that differ in the number of tornadoes that they get, but also certainly differ in a lot of places, a lot of characteristics, right? So we're looking at, for example, what happens in Kansas when you have a really bad tornado year versus what happens in Kansas when things are not so bad. So I'm going to show you Some of the main results from this published paper first, where we're looking at whether the supply of charitable donations is fixed. So if we look at total donations in the IRS data, you see significant increases here. Point estimates are pretty small because, again, donations for disasters are a relatively small share of total donations, but we do see a significant increase in total giving. And so we look, at donors who are at least 20 miles away from the disaster. So we want to avoid income effects or anything else that's happening like right around the storm. When we look at charities in those same locations, so again, we're looking more than 20 miles away from the storm. Question is, do they have a negative effect because people are giving money, say, that they would have given to the local soup kitchen, instead giving it to the victims of the disaster who are 20 miles away? And we don't see any negative effect here, right? The point estimates are positive and not significant. And so in this published paper, we find that the dollar value is about $1.8 million per fatality caused by a tornado. And that is an increase in the total donations that people made. So not just donations to the charity, but their total giving that they claim in their tax return. So that says that if there's substitution between these different causes, that it's not perfect, right? If people just took dollars from the local library and instead gave them to the tornado victims, we'd see no increase in the total donations, but here we do see a significant increase. So there's not perfect substitution. And looking at the charities in the places that are near these donors who give more, we don't see any negative effect. And so it looks like most of this giving is new money, which is, I think, an interesting result in its own right, but is also important for the work that we're doing now, because now we're focusing more on the data from the American Red Cross. And so you could, raise the concern that maybe the donations to the Red Cross, maybe they go up, but total donations, don't change because people give that money and would have otherwise given it to some other cause. It looks, according to our first study here, like much of this is actually new giving. And so we can actually study donations to the Red Cross and try to get at some of these other questions. So we want to know, for example, do these transfers depend on the identity of the victims? And so here we're moving into much newer work that we're doing. And so you're going to see a lot of these results are super preliminary. I'm very much interested in hearing any thoughts that you all have. We know that climate change is increasing the frequency and the severity of disasters. And we also know that people are moving disproportionately to places that are subject to these types of disasters, right? So more and more people are going to be experiencing these things. And so we would like to know how well our public institutions, as well as private philanthropy, are going to support people. So I mentioned insurance in the beginning. This is one potential solution. If everybody bought insurance against these natural disasters, that could potentially solve this problem. But there are a lot of reasons to think that either people won't purchase insurance, even if it's reasonably priced, or that there will be market failures such that the insurance won't be reasonably priced. And so if people can't get good insurance, then that suggests we might need these other forms of support. So we're looking at whether charitable giving will respond to these increases in need. Let me maybe not spend a ton of time on the theory slide here, but there are a couple of theory papers that suggest that there are a variety of reasons why people donate. So maybe they actually care about the well-being of the people they're giving to, or maybe they just care about the amount of their own donation. And so depending on the relative importance of those things, people may or may not respond to actual increases in need that are caused by more severe storms. So I would sort of describe this as an area where the theory doesn't give very strong predictions. And so we need to get empirical estimates of how much people respond to the severity of storms. So we're gonna estimate how much charitable giving responds to severity of these natural disasters. And so there are a number of papers that have tried to do this in the past. I would say some advantages of the work that we're doing is that, as I said, these tornadoes, I think, are a relatively good natural experiment, because I live in Illinois. I know that we have some tornado risk, but I don't know on any given day or even in any given year whether or not we're going to get a bad tornado. And so you get some quasi-random variation in the severity of these disasters. And we're going to be looking at data sets that capture a very broad set of transfers that are arising because these disasters occur. So, as I said, we've got data now from the American Red Cross. So they shared with us some transaction level donation records. So we've got an observation for each donation that was made. We don't know the identity of the donor, but we know their zip code. And so we can do distance calculations. That's kind of the main thing that we've done so far. They also attach a fund to which the donor is giving. I think we might do something with that in the future, but we haven't at this point. So on the right-hand side here, the key variable is going to be how severe are these disasters? And we have a couple of options for measures of the severity of these natural disasters. So we know how many fatalities they cause, we know how many injuries, and we have an estimate of the property damage that results. And you could argue for any one of these. So in our published paper, for example, we focus on fatalities because we think that has the least measurement error. And with the IRS data, where disaster giving is a small percentage of total giving, we didn't have a lot of precision to do a lot of different things. But in the current paper, where Red Cross donations have a lot to do with disasters, we could actually break this down a little bit. And so we figure probably all of these things matter. There's probably sort of a common component of disaster severity that increases all of these things. And so we're going to use principal component analysis to try to figure out what this thing is. So we're going to take each of these three measures, transform them with the inverse hyperbolic sign, as I mentioned before. We're going to standardize these to have mean 0 and standard deviation 1, and then estimate the line that is the best fit to the combination of these three measures. And so you can see in the figures here, both of these have the transformed fatalities on the x-axis. The left panel here has injuries, transformed injuries on the left, on the y-axis. The right panel has transformed property damage on the y-axis. And you see that actually, once you do this transformation, these things all seem to be fairly linearly related to each other. So if you have, for example, a 10% increase in injuries, you're likely to see a 10% increase in property damages. And so what the principal component analysis does is it kind of gives you the best fit to these three measures. I've got down here at the bottom of the slide the actual estimates that come out of this, and they're pretty equally weighted among these three measures, right? So all of these are kind of capturing some extent of the severity of the disaster. So we're going to focus on the first principal component, which is kind of the line that best fits all three of these measures. We've looked at the second component, which seems to kind of distinguish between disasters that cause more fatalities versus more property damage. And we haven't seen much of a difference along that dimension. But certainly that's something that we're going to be doing more robustness checks on before we try to put a paper out. Okay, so in this table, what you see is the response of inverse hyperbolic sine donations to the severity measure. So the first column here is showing you the equivalent of the specification that we estimated in our published paper. So you see a very statistically strong positive relationship between the two. So when you have much worse disasters, you have much more charitable giving. And in our first paper using the IRS data, that was about the best that we could do. But now, because this relationship is so precise, we can actually look at nonlinearities in this relationship. So we can look at, for example, whether having any disaster that was recorded is something that increases donations. And we see sort of a marginally significant positive effect on that. We also add in polynomials to allow for more and more flexibility in this relationship. And if you look at the adjusted R squared here, you see that it actually increases with each of these columns. So apparently it's not a linear relationship here. It looks to be very non-linear. And I think that's something we need to get a better handle on. So my suspicion at this point is that this sort of non-linearity in state year severity is coming from maybe a more local response to particular disasters that happen at particular times. So maybe the correct functional form here is something like not just the sum of severity over state and year, but maybe different variables for different severity levels occurring at different points in time over the year. So one way that we've gotten at this a little bit is to exploit the fact that we have daily level data from the Red Cross. So we can look at how do donations respond by day following the disaster that occurred. And so you see a significant increase here over the first certainly 100 days. And by about 200 days later, this seems to flatten out. These estimates are all statistically indistinguishable. So it looks like most of the response occurs within about 200 days, which is something that I think we can exploit more. We've run a lot of regressions so far at kind of the state year level, just because it's much faster to collapse the data to the annual level. But I think our nonlinearity results are suggesting that we need to actually allow for more of this type of flexibility. Similarly, we can look at effects by distance from the disaster. So here the x-axis is how many miles away you are from this tornado. And so you kind of see what you might expect here with the largest responses occurring for tornadoes that struck people living closest to you. For a number of reasons, this graph is very preliminary. We have other versions of this where we have split this by whether, this 20 miles away is within your own state versus in a different state. And it looks like we're getting different responses there. But given this very complicated nonlinear function, we're still working on trying to understand what is the functional form there, which I think is necessary in order to understand the heterogeneity in the response. And similarly, if we, for example, split these zip codes according to socioeconomic characteristics, like what percentage of your population is white. So if we split by the median here, so we have donor zip codes that are above median in terms of the share of population that is white versus below median in terms of the share that is white, we can look at whether their donation patterns are different, in particular, whether they give differently based on the population shares in the victim zip codes, right? And again, this is super preliminary. I'm a little bit troubled by the fact that none of these estimates by themselves are statistically significant. I think we probably have some issues here with the data construction that we need to revisit, because it should be that at least one of these is significantly positive, right? Because we know that the overall response is significantly positive, and we don't see that here. But it looks like whiter zip codes give to whiter zip codes, and less white zip codes give to less white zip codes, and that the opposite is true when you're talking about giving to a zip code that doesn't look like you in terms of the percentage of people who are white. So this is our sort of first cut at this type of heterogeneity analysis, where I think what we want to do is a difference in difference, where we're comparing among high white zip codes, for example, in how much they donate to high white victims versus low white victims, and then compare that to the difference for the low white donors. And then this difference in difference should give us an estimate, I think, of racial bias. But maybe this split by the median is, again, not the right functional form. That's kind of the first thing we thought to do, but I think we need to kick the tires on that a lot more. So the last part here that we're thinking about is news coverage. So we're thinking this is probably a different paper, although maybe it depends how things go with the second question. If we see large racial differences in giving, then we might want to test whether the news either amplifies or ameliorates those differences. So that's another thing that we're currently working on. I'll just show you a couple of graphs we've done here and try to get to the Q&A. So so far what we've done is we've put news coverage on the left-hand side. So here we've got minutes of TV coverage, and you see that with more fatalities, you see a spike in TV coverage over the next handful of days. Similarly, if you look at newspaper coverage, which we have fortunately access to a very nice database of newspaper coverage, you see a significant increase over about the next week or so. What we want to do now is put news coverage on the right-hand side. So we want to create instruments for news coverage that would allow us to estimate the causal effect of the news coverage on donations. So we've started doing that. There are some papers in the literature that do this based on how much news coverage in, say, the last few days was concentrated on a couple of big stories. And we've got some preliminary results on that look pretty promising. But again, very much work in progress. So I think I'll end it here and open up to questions. very, very curious to hear what anyone has to think. So thank you again for having me, and thank you in advance for all of your questions.
Great, thank you, Ben. That was a really clear presentation. I really appreciate it. So if people want to type in questions in the Q&A, I will read off the questions. We have one question from Joel, and I have a couple of questions myself. But as people have questions, feel free to type them, and I see Jessica raise her hand. So let me read Joel's question first. So Joel asked, regarding the possibility of a private market for disaster insurance, isn't it the case that the federal government offers some subsidized products like flood insurance? Do you have a sense of how important that is for crowding out private insurance?
Yeah, that's a good question. So my co-author on this work, Tatiana Deryugina, is an environmental economist, and she has actually done some work on the public insurance that is available. So she and I agree that we need a good estimate of the crowd out effects of this public disaster insurance, and we don't know of any good estimates, and coming up with a really good instrument is tricky, right? So she has said to me, you know, the minute that we could come up with a good instrument for the amount of public provision, we should definitely write that paper. I think it's tricky to do so because, you know, the government insurance is supposed to be sort of available to everybody. It's kind of, you know, the pricing of it kind of depends on the riskiness of the location that you live in. All, you know, any sort of instrumental variable design requires some thinking to come up with an instrument that you can credibly argue is related to that X and not otherwise related to the Y. So it's something that, you know, we would love to do, but don't have a great idea on yet. And I don't think there's anything in the literature that that has really pinned down that crowd out effect.
Great, thanks, Ben. Jessica, I'm going to unmute you and you can ask your question.
Hi, Ben. I'm speaking not as an economist or any sort of expert in any of this stuff, but I lived in Alabama for 23 years, and I've lived through many a tornado disaster. And I was curious about a couple of the like non-linearity things and even some of the causal stuff with news coverage. And I think there's a question in QA that might get to some of this, but I'm wondering if in how you determine fatality, or not fatality, intensity and stuff, if y'all are separating out supercells from regular tornadoes. And so there have been many, but like 2011 is a great example, and it happened all over the country. But in the state of Alabama, there were 300 tornadoes that touched down that day. And so I'm curious, like, especially if you're thinking about causal stuff for news, not only is there this sort of different type of tornado event where a single tornado, even if it is large, could damage anything on its path, that's very different than hundreds of tornadoes all over most of the southern US in a single day. But also in terms of news coverage, that supercell window really lasted several weeks, right? And so in terms of like inundation of news, and then also if a tornado were to cause a lot of damage, but only in a rural area, what kind of news coverage? And so I'm just curious if y'all have thought about some of these things that are sort of particular to tornadoes as a disaster, as opposed to maybe some other kind.
Yeah, so a few thoughts, because I think you raised a number of important issues there. So I think the non-linearity that we're seeing in this kind of state year aggregate suggests that people are not just responding based on the total amount of damages that occurred in a state in a year, right? So I think that if you have one day where you have $10 million worth of damages, that might be different from having 10 different days where each day you had $1 million worth of damages. I honestly don't know what's the best way at kind of getting at that functional form. I think maybe some machine learning type of approach might be best, which is not an area of expertise for me. So I'm definitely open to any suggestions that people have. But I think, you know, we probably want to allow for things like, do you have a supercell in that year? Do you know, what is the aggregate, but also what was, you know, the maximum in different months of the year, things like that. I think that may get more at the actual functional form. What else? So you mentioned affecting rural areas versus other areas. So that's
and sort of the way news would cover that in terms of your causal thing, right? There's going to be a differential type of coverage and also longevity of coverage based on how many tornadoes and the geographic spread.
That's right. Yeah. So so there is a QJE paper by Eisenstein and Stromberg where they look at giving to international disasters. And they have a couple of instruments. The most entertaining one, I think, is the Olympics. So when the Olympics are happening, the news is focused on the Olympics, and so you don't get as much information about the disasters. And so I think we can use something similar to that, or to their other instrument, which is basically like, you know, disaster occurs at time T. How much of the news over time T-1 was focused on particular stories? If a lot of it was focused on particular stories, those are probably big stories that are going to continue. And so those are going to crowd out coverage of the disaster. And so arguably should be unrelated to the donation response. So that can be an instrument for the news coverage. But we're at a very early stage on that stuff, so we'll see where that goes.
Thank you.
Mm-hmm. Thank you.
Thanks, Ben. So we've actually got a number of questions been typed into the chat and into the Q&A. So Alicia asks, do you plan to distinguish national versus local news coverage? And since local media coverage tends to be within state, plan to control for that when looking at the effect of distance on donations. And you touched on it in your presentation a little bit about state, and I know you and I talked about it, where you're finding bigger effects for in-state donations, and maybe you could talk about why you think that's true, and maybe Alicia's conjectures, maybe it's the local news media focusing on in-state disasters.
Yeah, great question. So so I don't yet have a nice sort of figure showing this, but it does look like people donate more within state than they do out of state. So I'm in Eastern Illinois, 20 miles to my east is in Indiana, 20 miles to my west is in Illinois. And it looks like I would give more to the victims 20 miles to my west who are in Illinois than those 20 miles to my east in Indiana. And one of the potential explanations for that is media markets, some of which tend to follow state borders. So I think one thing that we want to do is kind of look at whether you see this in-state preference in places where the media border is different from the state border. If it's only occurring in places where the media border is the same as the state border, then I think we would interpret this as a media effect, right? If you still see it in other places, so you know, maybe I'm getting the same news as the people in Western Indiana, then you might think it's actually, you know, my affinity for Illinoisans rather than Indianans, and that I think would sort of connect with the affinity stuff that we're thinking about with the identity and social distance heterogeneity measures. So that's one thought on how we can get at that is look at places where the media border is the same as the state border versus places where those two borders are different. And any other suggestions on how we can look at that would be very welcome.
Thanks. Hiwat asks if you've looked at variation in news coverage of natural disasters by racial, ethnic, or income composition of the communities affected. Similarly, Anne asks about, do you think donations to Red Cross are representative of all disaster-related charities by different racial and ethnic subgroups of the population nearby? So if you could maybe combine those questions, that'd be great.
Yeah. So we're not far enough along to say much about that, but that's definitely something that we want to look at. So let me see if. So like in these regressions where we're splitting, for example, the victim populations by their characteristics, we can see, for example, whether there is more giving to a place of higher socioeconomic status or lower socioeconomic status. And media would definitely be one of the potential explanations for that. So we definitely want to look at whether, whether a tornado of a given severity gets more attention if it hits an area that is more white versus an area that is less white, or an area that is higher income versus an area that is lower income. We're not there yet, but that's very high on our priority list. And the other question
about representativeness of the Red Cross for by race.
Yeah. So that's hard to say, right? Is the giving to the Red Cross representative of total giving? I would say that one other tool that we have at our disposal is the data from charities more generally. So all charities have to file these forms with the IRS each year. And so we can look at donations received by charities. So I didn't show you this, but we have a table on this in our published paper where you do see an increase in donations received among charities that are in tornado locations. And so I think that's one thing that we could use to sort of assess whether the giving to the Red Cross was representative to giving to other causes. But I'd certainly be happy to hear any other suggestions.
Great. Latonya writes, I learned a lot about the phenomena of transfers after disasters, but I'm wondering if you could speak a little bit to what you think the work on the phenomena tells us about human behavior or social forces at work in the phenomena.
Yeah, and that's, I think, an interesting question for how we write this paper. So part of the challenge actually in creating some of these graphs, which I didn't appreciate going into this, is that you can estimate sort of the response at the donor level, and that can be different from the support that is received by the victims, right? So let me see if I can give you an example. So let's say that I'm in a low income area and everybody around me increases their giving by 5% when I have a bad tornado. And maybe that's no different from other places. So if I'm in a high income city and maybe people also increase their giving by 5% when I have a bad tornado, but the outcomes are going to be very different in those two situations, right? So in both cases, maybe the human behavior is the same. So everybody increases their giving by 5% when their neighbors have one of these experiences, but that can lead to very different outcomes depending on where I live. And so that, I think, is something we I think we're going to try to speak to both of those things in writing the paper. So I think, to understand both on the donor side, are there systematic differences? Are people more likely to give to people who look like them? But also from the victim's perspective, are you worse off if you happen to live in a more rural area or a more low income area? Because even the same proportional responses among the people around you could result in different amounts of transfers that you receive in the end.
Great, thanks, Ben. I think we got 30 seconds left, so I'll just ask the last two questions. Isabel asks, have you considered looking at coverage on social media, Twitter, Facebook, in addition to TV news coverage? And Sarah notes it'd be interesting to look at Kansas City with regard to state lines of news coverage, because Kansas City spans Kansas and Missouri. I grew up in Cincinnati, and I would also think that might be worthwhile looking at as well.
Yep. Both great ideas. We have looked a little bit at Google search. And so we find, for example, that you are more likely to search for a tornado that is within your state than one that is in the neighboring state. So that's kind of consistent with some of our other results. But haven't looked at others. So maybe we should think about that. Sorry, the second one again.
Oh, looking at boundaries, cities like Kansas City.
Oh, yeah. Also something that's on our to-do list. So, we've got these estimates by distance from the tornado, and we've got them broken down by whether this occurred within your state or without. I think we definitely need to create a variable. So the reason that a lot of this is taking longer than I would like is because it's a lot of wrangling of spatial data that turns out to take a long time to run. But I think, it's important to not just be comparing, differences in behavior among people who live near borders versus people who live in the center of their state, but actually, among people who live near the border, do they give in a different way to the people who are just on the other side of the border versus just on their own side?
All right, I want to thank Ben and thank everyone for coming. For students attending the post-seminar discussion, there's a link in the chat, and Peter also posted a link for all the future CSD talks. So thank you, Ben, appreciate it, and it's good to see you. Bye, everyone.
Ben, I sent you a message if you didn't see it, but I'm happy to send it in an email if you want.
Okay, yeah, the chat has that link for the students. Wow.